there are certain variables that decide the state of the system, a thermodynamic system. All right. So, what are these? These are pressure, volume, temperature, number of moles, enthalpy, internal energy. So, these systems, these variables are actually state functions. What does that mean? It means that if state of a thermodynamic system changes, then these variables will change, or any of these if variable change, that means the state of the system is changing. All right. So, these are not dependent on the path, these are dependent on the state. All right. So, if state changes, then these variable change. If state does not change, these variable do not change. For example, if we have a reversible process or a cyclic process for that matter, I take a cyclic process, pressure, volume. All right. If I take a cyclic process starting from point A and I go to B, all right, and I come back to A. So, what do you think? Will there be any change in the variables or state functions? No, not at all, because initial state was A and final state is A. So, there is no change in state of the thermodynamic systems. So, the variables of pressure, volume, temperature, number of moles will also be same. Alright. So, there is no state change. So, no change in the values of state function variables. Alright. So, the state functions do not depend on path, they depend only on change in state. Alright. Now, so for a cyclic process, change in temperature delta T equals to 0, change in volume delta V equals to 0, change in pressure delta P equals to 0, change in internal energy equals to 0, enthalpy change equals to 0. So, all the changes for a cyclic process are same because initial state was A and final state is A. You went in a cyclic manner and came back to the same point. So, when there is no change in state, there is no change in the value of state functions. Alright. So, this is it about state functions. Now, we have certain thermodynamic processes which are adiabatic process, isobaric process, isothermal, isochoric process. What is unique about them? In a adiabatic process, there is no net heat transfer. So, Q that defines heat transfer equals to 0. So, there is no heat transfer during adiabatic process. All right. So, Q equals to 0 for adiabatic process. Isothermal process is a process in which temperature throughout the process remains same. Isothermal process, temperature remains same throughout the process. So, delta T equals to 0 for isothermal process. Alright. Next is isochoric. Volume remains same throughout the process, that means change in volume equals to 0 for isochoric process. And isobaric means pressure is constant, that means there is no change in pressure. So, delta P equals to 0 for isobaric process. So, isochoric done, isobaric done, we have everything written over here. Adiabatic Q equals to 0, isothermal delta T equals to 0, isobaric delta P equals to 0, isochoric delta V equals to 0. We have a graph out here where what do you see? You have a graph where in an isobaric graph you are getting at the top, then isothermal, then adiabatic and isochoric because volume is constant. So, work done in an isobaric is the maximum, then work done in isothermal and adiabatic, and minimum in isochoric, because we look at volume change. So, volume change in an isochoric process is 0. So, work done in expansion or compression in a isochoric process equals to 0. Alright. We have reversible and irreversible process. What do you think reversible process is? Reversible process is a very slow process in which there is equilibrium at each step, and irreversible process is a fast process that happens in finite number of steps. Reversible, very slow, infinite steps. Irreversible, very fast, you can count the steps, 2 steps, 3 steps, 4 steps. So if you can count the steps, that means it is a irreversible process. If you cannot count the number of steps, because infinite steps are there, because it is very slow process, it is reversible, fast process, irreversible. What do you think? Are real processes are reversible or irreversible? I think you will agree we cannot have a process which is damn slow, right? So we do not in real life have reversible process. Processes in real life are irreversible, fast processes, right? So these are few explanations, and what where work done will be more, a process which is very slow or a process which is quick. I think you will agree reversible process which is very slow will always have greater work done. All right, an irreversible process will have lesser work done, right? Next, heat. What is heat? Heat is basically the transfer of energy in the form of heat. All right. So if there is no net transfer of heat, then the process is known as adiabatic process. And where do we find that? When the external boundaries are insulated, that means you have non-conducting boundaries, then you have adiabatic process and heat transfer equals to 0. Right. Next, there is a formula you must have seen, that if you want to calculate heat transfer, then what you can use is Q equals to ms delta T. What is M? M is mass, S is specific heat, and delta T is temperature change we want to make. So this is it.